Hello, friends. How are you? All of you are doing fine. I think the situations are becoming normal day by day. I hope you are still taking precautions so that none of you get infected and you are preparing well. So, this is another question. This is a very interesting question. Conceptually, a little bit challenging, not much difficult. If you get the line, if you struck the right string, then definitely it will produce a fine tune. Anyway, without wasting much time, let's proceed. So the statement of the question is saying a balloon with surface tension gamma, and they are saying that don't get confused with the adiabatic exponent anyway, is placed in a vacuum chamber connected with a small tube to a gas container with piston. The total number of moles of gas in the balloon and the piston is n. The system is allowed to equilibrate such that the pressure of the gas in the combined system is P naught if the system is maintained at a constant temperature T. Wow. This is the point we have to remember while solving the question anyway. The pressure on the piston is quasi-statically varied. What do you mean by quasi-static process? Quasi-static process is a process which appears to be static but not static because of infinitesimal variation in any of the thermodynamic coordinate. When a system moves from one step to another step by maintaining equilibrium at each and every single instant, that process is called quasi-static process. Hence, in quasi-static process, system will be in equilibrium at each and every instant. That is a point you have to remember. Anyway, it is appearing to be a tongue twister anyway. So that such the system is always thermodynamic equilibrium until all the gas molecules in the piston are transferred to the balloon. Determine the amount of work done on the gas by the piston. The final pressure of the gas is P1. Assume that the balloon constantly maintains a spherical shape. Okay, done. So it will also have two methods. I will show you one method, another method you have to work out and do let me in the comment box. So first method, since it is in equilibrium, so I can comfortably write P equal to excess pressure equation 2 gamma by R. Simple. Now, I will consider that at this instant of time, here the volume is V and the radius of the spherical balloon is R. So total volume becomes V per plus 4/3 pi R cube. Now from PV equal to nRT, we can write P into V plus 4/3 pi R cube is equal to nRT. From there I will get P value. We have already seen that P is equal to 2 gamma by R. From there I am segregating R value and substituting in this equation to get segregated or to separate V. Now here I have separated V, as you can check. Right. So here V is separated in terms of small r, which is a variable. So if I do dV equal to, we get minus of nRT by P square into 32 pi R cube divided by P to the power 4 dP. Work done equal to, since you are talking about work done on the gas, so negative, W equal to minus P dV. So if I integrate the result from P naught to P1, we will get the answer W equal to nRT P1 by P naught 16 pi gamma cube by P1 square minus of 16 pi gamma cube by P naught square. Fine, done. Method 2. ज़रा सोच ले बउआ, तब तक इसको शेयर करते रहो और देखते रहो. बाय बाय.